In this video, I want to go through the solution code for Professor Goldluck's 5. So we discussed the solution idea, the states to be kept, and so on in the last video. So here, let's look at how to implement this in the code. So yeah, we need the variables for the max PPSF and also the minimum admissible PPSF. So the list PPSF among all admissible housing. Then there are a group of variables for storing information for the 3 houses. So the previous house, the current house, and the committed house. So in addition to this information of price, footage, and number of rooms, we also store whether they are admissible and their PPSF. So whether they are admissible or not, and PPSF can be computed from these 3 information: price, number of rooms, and footage. But it's better to compute it once and store this information mostly for readability. So if you see the code, you see the variable name, admissible, you know what it means. So creating variables to store pre-computed information and give good name to it will help make the program more readable. For committed house, we don't store whether it's admissible or not, because by definition they are admissible. Otherwise, we shouldn't commit to them. And for every of these variable, we assign an initial value. So this is a good habit because most of the many times this variable will be overwritten, so it's not used. But having initial variable is it's a good habit. Otherwise, sometimes the compiler will complain when you want to use a variable and it's not initialized. So and also sometimes even though you know this variable will be initialized, the compiler cannot figure that out. So for example, here we declare the variable footage, rooms, and price, which will be used after this loop. So actually rather the PPSF and so on. So you know that the number of houses will be greater than 0. So this body of the loop will be executed at least once. But there's no way for the compiler to figure that out, because that depends on the number n that you read in. If you read in a number of 0 or -1 even, then the body of the loop is not executed at all. So then this variable will not be assigned before the code after the loop. So then the compiler will complain that this variable are not initialized if you use them after the loop. So inside the loop, so we are looping this n days for the n houses. So we compute which phase we are in. So again, using a variable name so that the condition will be easier to read. And then we compute reading information of the current house and then compute the PPSF and whether they are admissible or not. And then we update the maximum PPSF and the minimum admissible PPSF here. So then the rest of this code in the loop is sort of the main part. So this is the part that's hard. So particularly, basically, this if statement. This is the hard part to get right. Because what we do depends on a lot of conditions. It depends on information of the previous house, information of the current house. But primarily, the first level difference, it depends on which state we are in, there are 2 important factors. One is whether there's a committed house or not, and the other is which phase we are in. So the code, I think the natural thing is to choose one of these as the outmost layer if condition. So we can say based on the phase, whether we are in phase 1 or phase 2, we will do one thing or the other. But I chose to make the outermost distinction based on whether there is a committed house or not, because I feel that's the that will result in the most difference, whether there's a committed house or not. The logic will be most different. So the outermost is whether there is a committed house, which I just use this committed price variable to check. If there is a committed house, because no house has a price of a 0, so then the committed price variable should be greater than 0. If no house has been committed, because I initially assigned a 0 to it, then the value should be 0. So this line is from when I was debugging the code for my own problem. So I left it here so that you can see what kind of things I use when I debug. So I print information out. I essentially print all the information, all the important information, or from my point of view, important information out. So I print the current house information, price, room footage, the PPSF, and here I also printed the committed house PPSF. I guess this was because I was expecting a house to be changed, but it isn't. So I print the information to help me judge what's going on here. So if there isn't a committed house, then if there is a committed house, then what happens is we may decide that the current house is much better than a committed house. So then we'll simply buy that house, and then we will end. So that will happen when first the house is admissible. So the current house is admissible, and the PPSF is less than or equal to committed PPSF minus 5.7. So when that happens, then we just print out the information of the current house and print out the information of the committed house, and then we're done. So that's the committed part. If there is already a committed house, then we really don't need to do anything else. That's all we need to do is to check whether the current house is much better, significantly better than the committed house, and then we'll buy it and we're done. So the other case is there isn't a committed house. So in this case, we need to check whether we need to commit to the house available to the previous day. So in fact, what happened is we are essentially checking a series of conditions. The first thing here, the first thing my code checks is whether the previous house is admissible. If it's not, then we don't need to do anything. If the previous house is admissible, then the next thing I check is whether it satisfies the conditions specified in the strategy. So there are two possibilities that I may decide that we should commit to this house. First is the price, the PPSF, is less than or equal to half of the maximum PPSF. So, and second is if we are in phase 2, and this house PPSF is less than or equal to the minimum we've seen so far. So if this is satisfied, so this is a logical OR. Either this is true or this is true. And within the second OR branch, we use a logical AND because this condition is applicable only when second phase. So when this is satisfied, we still can't just decide to commit to that house because it may be that the current house is even better. So we have to make sure that the current house is not better. So that will happen either the current house is not admissible, in which case it doesn't matter what PPSF it has. So we will definitely commit to the previous house. Or the current house PPSF is greater than or equal to the previous one. So the previous one is better. So in which case, in fact, I think here it really should be less than is more correct, because if it's equal, we can wait. But all the test data is ensured that no two houses has the same PPSF, so it doesn't really matter. But logically, it should be less than. So when when all of these conditions are satisfied, we commit to the previous house. So we do that by copying the previous house information into the committed house information variables. So at the end of this loop, we move the current house information into previous house. So this is our 5 assignment statement. So that's the loop. So one thing that we didn't do is we didn't, because we always we only commit to a house if it's the previous day's house. So we never sort of never have a chance to commit to the house available on the last day. So this is because that is special. We handle it outside the loop, and when the loop ends, the information this price, room, footage, PPSF, they refer to the last house, the house available on the last day by the time the loop ends. So the condition is if we do not have a committed house and the current house is admissible, then we will check whether the current house is worthwhile. So at this point, we know on the last day, we definitely in phase 2. So the condition can be simplified to be either PPSF is less than or equal to half, or PPSF is less than or equal to the minimum admissible. So in that case, we actually commit to that house. So this is the last part, just printing the result. So either we do not have a committed house, in which case we'll print this, or we have a committed house, which case we'll print this. So we will not reach this point if we have committed to the house and then saw a house that's better and then we buy it. For example, yeah, so there is one sort of a slightly tricky case. So what if the fifth house, is it possible to commit to the fifth house and then buy the sixth house? No, I mean commit to the house available on the second to the last day and buy the house that's become available on the last day. So that is not possible because we will decide that on day 6. Decide whether to commit to the house. I always say 6 because most of the sample test case have 6 days. But we will decide to commit to the house available on day n-1 on the last day. But we will commit to that house only when the last day is worse or the last day is no better. So it's not possible that we will commit to house available on the day second to the last day and then find out the house available on the last day is better. Okay.